Hello everyone, I'm Connor, and today we'll be going over the December 2022 USACO Silver, Problem 3, Range Reconstruction. So in this problem, we're given Bessie has a secret array, and we are given the range of every subarray, and we have to try and figure out what Bessie's secret array could possibly be. So here's one example. We have this secret array with unknown elements, and we know the range of every subarray. So for instance, we know the range of this element by itself is 0. Same for the second element and the third element. And we know that the range of the first and second element is 2, and the second and third element is 1. And finally, we know the range of all three elements is 2. So we have to try and figure out what Bessie's array is from this information. So the answer for this sample input was 1, 3, 2. And we can see that this satisfies the ranges. So if I just put it here, we see that the range of each element by itself is 0, and that's going to be true for pretty much every element. We know that the range from 1 to 3 is 2, since the max in that subarray is 3 and the minimum is 1. We know the range from 3 to 2 is going to be 1, which satisfies that. And we know the range of the entire thing is going to be 2, since the maximum is 3 and the minimum is 1. So how can we approach this problem? A hint is given in the problem name itself, range reconstruction. And this construction part is especially interesting, because our goal is to ultimately construct an array that has the correct ranges. So, and the best way to do this is to start from the beginning. So one idea we can do is start from the first array element, and then build out the rest of the array from there. So what we choose as this first element? Well, it turns out we can actually choose anything, because an important thing to notice is that no matter what the starting element is, we can construct a valid array for it. And if we have like this sample input here, we can actually just like add 1 to each element, and then we get 2, 4, 3. And this turns out to be a valid array as well, since all the ranges still match up. And then we can like subtract 10 from everything and get like -8, -6, and -7. And this still is a valid array. And the reason we're able to manipulate the array in this way is because when we add or subtract something from every element in the array, the relative values don't change at all. And since the range is only the difference of the minimum and maximum elements, this difference doesn't change if we add the same amount to the minimum and the maximum elements. So it turns out we can actually choose whatever we like for this first element of the array. So what's the best thing to choose then? One idea is to choose 0. And the reason for choosing 0 is because it's like a neutral element in the middle of everything. In the problem, we are told that we can output any value from 10 to the 9 to -10 to the 9. And 0 is exactly in the middle of these. And this actually turns out to be pretty important, because one thing to notice in the problem is that Bessie's array can go only from 0 to 10 to the 9, and it doesn't include any negative numbers at all. And the reason for this is because we want to build every consecutive element kind of relative to this first element. And if it's relative, then that means that we can't choose numbers arbitrarily. If Bessie's original array started with 10 to the 9 and then went down to 0 at some point, if we started with 0 in our reconstructed array, then this might go down to -10 to the 9. But if we started with something like -1, then this would go to -10 to the 9 minus 1, which is out of range, so that's not good. So starting with 0 kind of ensures that no matter what Bessie's original array was, we'll always be in the range that's permitted by the problem. So now we've chosen the first element to be 0. What do we want to choose for the second element then? Well, we said that earlier we wanted to build this array kind of relative to the first element. So it turns out there's actually not that much choice we have in making the second element, since we're restricted by the limitation of this first range here. We know that the range from the first to second element is 2 in this case. So that means that the difference between the maximum and the minimum elements is 2. And this really restricts our possibilities for the second element, since we know that the difference between it and the first element, which is 0, is going to be 2. So that means that we have two possibilities for the second element. We can have it either be 2, or we can have it be -2. And both of these result in a valid range of 2. We can't choose any other element or it'll result in some invalid range. So which one do we choose here? Do we want to choose 2 or do we want to choose -2? Well, it turns out it doesn't actually matter. We can actually choose either one here. And this is because if we kind of reflect each array element around the first element, then it'll generate a valid solution as well. For instance, if we took this 1, 3, 2 solution, we can actually turn this into 1, -1, 0, which is kind of reflecting the array around the element 1. So that this gives us a valid solution as well. We can check that this range is 2, we can check that this range is 1, we can check the entire range is also 2. So this is still a valid solution. So this is actually like the most arbitrary step in our solution, where we can choose either that the second element be higher than the first one, or it for it to be lower. And in my solution, I decided to choose it being higher, but you can create just as correct a solution if you choose lower. Alright, so we've chosen our first two elements, but now we want to choose the third one. So we can do kind of a similar thing we did with the first element, where we know that the range between here is going to be 1. So this gives us again two possibilities for this third element here. We can either have this go up to 3, which has a range of 1 in this small subarray, or it could go down to 1. This time though, we can't choose as arbitrarily, because you'll notice that if we choose our 3 here, then that'll lead us to have an array of 0 to 3. And this violates the rule that the entire range must be 2, which doesn't work here because the range is actually 3, between 3 and 0. So this time there's only one correct choice, and that choice is to go down here to 1. So how do we figure out which one is the correct choice? Well, one way you can do it is you can look at all the prior ranges, including this element, and see if it satisfies all of them. So take this array, for example. We have 3, 6, 5, 2, 2, and now we have an option to go between 4 and 0, because we know that this range here from 2 to the next element is 2. So either one of these could be correct when only looking at this range. But if we take more ranges into account, if we look at this range here from this 2 to the new element, well, it's going to be 2 as well. So both of these are valid for that range. So we go one range further back. And if you look at the range from this 5 to the new element, we would see that the range has to be 5. And if we took this 4 here, then that actually wouldn't work, because that would give us 5, 2, 2, 4, and that only has a range of 3, which is not the 5 we want. So that cancels out this 4, and it leaves us with the only valid one to put there is 0. But how do we know that one of these options is actually going to be correct? We saw that when we looked at this range here with the 2, that it didn't actually cancel out either of these options. So how do we know there's actually going to be anything that makes us choose one or the other? Well, it actually turns out that in all but for one special case, there is always going to be one correct choice for the next element. And to show this, I'm going to abstract it a little bit, and I'm going to turn the numbers into dots that represent the numbers. The higher a dot is, the higher its value is. So an important thing to notice is the only way in which both of these choices could be correct is if they lead to exact same range number. So let's say that we had two different numbers here. We had a high one and we had a low one. And then we can choose either to go up here or down here for the next range. And this kind of corresponds to something like 5, 2, and then we can choose either to go up to 4 or 0 or something like that. So it turns out that it's impossible for there to be two different choices here that are both correct. Because if we choose this higher option, then the range is going to be from this top element to the bottom element here. But if we choose the lower option, then the range is going to be from this top element all the way down to the new element. So since these two ranges are different, then we know that if we're given a number that must correspond to one of these ranges, only one of them is actually going to be correct. There are a couple of cases where this may not necessarily be true though. For instance, if the range between the next one is actually 0, then there's actually only one choice. And this choice has a certain range, and that range is always going to be correct. But since there's only one choice, we already know what to pick, so we don't really have to worry about that. So that's kind of a special case when the range here is 0. So that means we must always choose the same element. Another special case is if the two elements immediately preceding are not different. Like say we have, say like in this 522 case, the two elements right before it were exactly the same. So let me draw it in dot form down here. We could have either chosen 5224 or 0. If we were to look at the two dots immediately preceding, then we would see that the ranges are both the same. So if we looked at this dot here, it would result in this range. If we looked at this dot here, then it would result in this range. And both of these ranges are equal. So in this case, we actually have to look at the dot before it. So we continue going back until we see a dot that it actually is different. And once we find that, then we can do the range test. So if we take this dot over here, then we know the range is going to be this. And if we take the bottom dot over here, then we know the range is going to be this. And we're still only given one possible value for this range. So that means that only one of these ranges is going to be cancelled out. So in this case, if the two numbers immediately before the choice are equal, then we can keep going back to find a number that is different. And then we'll be able to choose from there since there's only one possible range. And there is one other special case that I mentioned. It's when there are actually no two numbers that are different. Since we're trying to go back and find two numbers that are different to determine the range, if there are none of that before, like all the numbers back to the start are all the same, and then we have to make a choice from here, then it actually turns out it's just like this case from up here with our first element. There's actually nothing special here. We can always just choose either one of these. And in my case, I always choose the higher one. The lower one works as well. And that's for the same reasoning as we can choose either 2 or -2 here. Both of them work equally well. Okay, now let's go over our solution one last time with the last sample case. So in our solution, we want to construct the array from the beginning, and our choice for the first element is 0. And this doesn't matter what we choose for that, but 0 is the best because it's right in the middle of our valid range of numbers. And then we wanted to look at the second element and choose that based off the range between the first and the second element. And that corresponds to this number. This number is saying that the difference between the first and second numbers is going to be 1. And if there are two valid numbers for that, we can have 1 or -1. And in our case, we always choose the higher one because it actually doesn't matter at all. So we choose 1 for our second number. Choosing the third number is a bit more complicated because we have to figure out which ranges are valid for it. So we look at this number. This number tells us that the difference between the second and third elements is going to be 0. And that actually makes it really simple for us because that means that there's actually only one option for the third number, and that is 1. Since the range between the second and third number is going to be 0, there's only one choice for that third number. And finally, we have the last number. And this last number is going to have a difference of 2 between that one and the third one. So there are two valid options here. We can either choose 3 for the last element, or we can choose -1 for the last element, since both of those have a difference of 2. But only one of these is going to be valid. And if we look at the previous ranges, we know this one has a range of 2. So that is correct with both of them. That corresponds to this number. This one has a range of 2 as well, which corresponds to this number. And that works for both of them as well. So we keep going back and then look at this range, which corresponds to this one. And this one also has a value of 2. And if we look at the two different numbers we have here, we have a 3, which means that if we put that 3 in, then the range of from 0 to 3 is going to be 3. And that's not 2 like we want. So we have to choose the -1 here, because if we choose the -1 here, then the full thing will have a range of 2, which does correspond to the number we're given. So then we choose our value here as -1, and that fulfills all of the ranges correctly. And this is actually different from the sample input solution, since the sample input solution is 1, 2, 2, 0. And this is actually okay, because like I mentioned, we can just subtract 1 or add 1 to either one of these solutions, and I'll still create a valid solution. And the USACO website will accept either of these solutions. All that matters is that they're choosing a different starting point. They're choosing 1 and we're choosing 0. So yeah, that's our solution idea. We start from the beginning. We look at the previous element to see what the possible numbers are for it for the next element are. And then we check all the ranges to see whether the range is valid, whether each choice is valid. So I'll show you my C++ code right now. So here's my C++ code for this problem. So I'm going to walk through this code step by step. So in this first part of the code, we read in our input, and we store it in this ranges array. And this ranges array stores for the 2 dimensions. The first dimension stores the starting index of each range, and the second dimension stores the ending index. And we do this 0 indexed. So the range from 0 to 2 will store the range of the subarray from 1 to 3. So, and this output array stores our output array. It starts with 0. Here we set output 0 to 0, since that's what our starting value is. And here we set output 1 to be 1, or to be equal to the range from 0 to 1. And that's basically the same as saying that this range here, we're arbitrarily choosing to go up, since if the range given is something like 2, then having the element 0 and then having the element 2 will produce us a valid range. And then now we start a for loop here. So we loop from 2 all the way up to n, but not including since it's 0 index. So we start from element number 3, and then we go all the way down to the end of the array. We have our special case here, which is that if our range is 0 between the last element and the current one, then we can just simply set the output of the current element to be equal to the output of the last element. And this is just saying that since the range is 0, there's only one possible value, which is the same as the previous array element. And now here, we have our 2 values here. We have our high value and our low value. And this corresponds to the split that we have. Like if we have the last element be 1 and our range be 2, then we can have either 3 as the next element, or we can have -1. So high value corresponds to 3, and low value corresponds to -1. And we just have a marker boolean here to see if we found a difference. and we'll use that later to see if we hit the special case. So now, as this comment says, we want to find the last change in the array elements. So we loop from the index p as I minus 2. So we start 2 elements back, and we're looking for a change with the next element. And that's what this if statement does. It compares that previous element to the next element. And this is the part of our procedure. We're trying to find a difference in the array values, because if we have a difference in the array values, then we know that only one of the ranges is going to be valid from there. So now we calculate the actual ranges of these values. We have a range high and range low, and that's given by these formulas, which look kind of complicated, but it's basically kind of a little bit cheating by not calculating the actual range. And it's only looking at the maximum of the current output and the high value, and the minimum of the output and the low value. So we don't actually have to calculate the entire range, since it's kind of a guarantee in our solution that this p is going to be the first difference, or the only difference like right beforehand for the element we're looking at. So like if we have our array that was like 3, 6, 5, 2, 2, and then we can go either to 4 or 0, then we know that we're looking at this last change here, which is 5, 2, and then we can calculate the maximum and minimum of the range, and then subtract them to get the calculated range. So next we have an if statement here. We check the actual value of the range and see which one of these high and low matches. So if the high matches, then we set the output to be the high value, and otherwise if the low matches, we set the output to be the low value. So we know that only one of these ranges is going to be correct, and then we set the output to that value. And then we set our marker boolean here, found difference, to be true. And the only case where found difference can be false is in that special case where all the array elements beforehand are equal. So since we start with 0, we have 0. And if our output array looks like this, and then we can go from here to 4 or -4, we're not going to have found a change at all in the previous elements, since none of these elements are different from each other. So in that case, found diff will never have been set to true, and that brings us to our special case if statement here. So, and as this comment notes, we can set it arbitrarily here, since both of these values are going to lead to correct solutions. So we can choose either 4 or -4 for this one, and we just set it to high value, which would be 4. So that if statement just deals with that special case. And then at the very end of the for loop, that means we've set all the values in our output array, and then we just print them out one by one. And one thing that kind of got me is I forgot to remove the space from the end of the output. It turns out USACO grader doesn't really like that when you have an extra space there. Some other websites allow that, but not USACO. So make sure that you don't have any trailing spaces at the end of your output. So yeah, that's the solution for the USACO Silver December 2022 problem 3. Thanks for watching.